Hello everyone. I've decided to create a little bit of a review for Exam 3, and I have this document posted, and I'll be sending it to you as an attachment as well to your T-Wolves email, but it's some guidelines for taking the exam. Don't forget to submit your homework, but some things to consider: you're on your honor, so please treat it as you would a proctor exam in class. So it would be nice if you didn't use your notes and just what the crib notes that I'm giving you. So those are posted as well. What the crib notes look like. Here's a copy. We've got the trial solutions, the formula for variation of parameters, other useful formulas, and then formulas for RC and RLC circuits. So it'd be nice if you only use that to take the exam. And there's a review posted as well. So you got the review for Exam 3, and the answers are on the second page. And what I'll be doing in these videos is going over selected problems and solving those for us. The exam's also posted in Exam 3 handouts. Everything is in the folder titled Exam 3 handouts that are under lecture notes and videos, which hopefully you've been watching. And I'm going to send you an email with the exam attached, as well as these guidelines. And when you submit the exam, please either scan it to me or take photos and email them to me as attachments. But in any case, make sure that I can read them. They're not upside down or sideways. And I would really appreciate that. And so these are the videos that I'm creating that are going to be just like us being in class and reviewing some selected problems. So here's the topics. You can read through those. And we'll be starting our review. So again, from the review for the exam, I just took selected problems, and starting with the first topic, particular solution by the method of undetermined coefficients. So remember, the way we start this is by first forming the associated homogeneous equation. So that's just setting our left-hand side equal to 0. Then we get the characteristic equation, and in this case it's r squared minus 3r minus 4 equaling 0. This one factors neatly as r minus 4, r plus 1. So r is 4 and r is negative 1. So those are real distinct roots. So the complementary solution or function, which is a solution to the homogeneous, is c1 e to the 4x plus c2 e to the negative 1x, or just negative x. Now remember, we make a guess as to what y sub p is based on the function, in this case 5e to the 4x. So we would say that our guess is a e to the 4x. And you can use the cheat sheet for that if you wanted to. That's a simple one, but if you want to do, something like number 6 here, tells you what to use. But again, that's a simple one. But then we compare, and if we compare these, we see that we compare the complementary with the particular, and we see that there are duplications. Now, I may just give you problems where there's no duplications in this area, because the next set of problems will take care of that concept. But since there all are duplications in the form of e to the 4x, we're going to have to multiply this guy by x. So we'll multiply by the least power such that there are no duplications. And so we take y sub p in this case to be ax e to the 4x. Okay, and then we're going to need a couple derivatives because we're going to substitute into the differential equation. So y sub p prime, first factor, ax times derivative of the second, derivative of e to the 4x, e to the 4x times 4. So let me write 4ax e to the 4x plus the second factor, because we're going to need the product rule here, e to the 4x times ax, times the derivative of ax, which is a, will just give us a e to the 4x. Okay, then y sub p double prime. Okay, product rule again on this term. 4ax is the first term times the derivative of the second, and the derivative of the second is e to the 4x times 4. So 16ax e to the 4x, then plus the second factor, e to the 4x times the derivative of the first, and the derivative of 4ax is 4a, so 4a e to the 4x, and then plus, so let me separate this so you know where it's coming from, the derivative of a e to the 4x, which is 4a e to the 4x. So it looks like we can combine these two 4a e to the 4x's, so plus 8a e to the 4x. Okay, so then we substitute, and we're substituting into the non-homogeneous given differential equation. And upon substitution, we get, okay, so we have y double prime, which is 16 ax e to the 4x plus 8 a e to the 4x minus 3 times y prime goes right here, 4ax e to the 4x plus a e to the 4x, and then minus 4 times y, which was ax e to the 4x, and that all must equal the 5 e to the 4x. And just to make things perfectly clear, let's recopy and show the basic algebra. Distributing the negative 3, we get negative 12ax e to the 4x minus 3a e to the 4x, and then here minus 4ax e to the 4x, and that equals the 5 e to the 4x. Okay, and then what always happens when we have a situation where we had to modify the given function by multiplying, or the guess by multiplying by a power of x, is those terms containing that x should disappear. And that's true because notice how the 16 ax e to the 4x goes away with this negative 12 and the negative 4 of them. So that all we have is 8a e to the 4x minus 3a e to the 4x, or 5a e to the 4x, now equaling 5 e to the 4x. So we can divide out the e to the 4x, we get 5a equals 5, and a is 1. So then our particular solution, y sub p, is equal to 1 e to the, the modified version, 1x e to the 4x, or just simply x e to the 4x. So there's a good example. And another one here. Start the same way. Associated homogeneous. So set it to 0. Y double prime minus 4y prime plus 3y is 0. Factor, oops, not factor, characteristic equation next. R squared minus 4r plus 3 is 0. Okay, this factors neatly as r minus 3, r minus 1. So r is 3, r is 1. Again, these are real distinct roots, so the complementary function c1 e to the 3x plus c2 e to the 1x, or just simply x. Okay, and then we make a guess for our particular solution. And it contains a cosine, but remember, if it contains a cosine, we have to include sine as well. Now, it could contain both. If it contains both, obviously we'll include both. But even if it just contains one of them, sine or cosine, we have to include both in our guess. So c1 cosine x plus c2 sine of x. And that's exemplified in the cheat sheet under number 5. Okay, so that shows you the situation. And again, even if you had 2 cosine 5x plus 3 sine 5x, it would be the same thing that you include, as long as the arguments are the same. Okay, so then we make a comparison, and there's no duplications. So our guess is good. So we take y sub p to be equal to c1 cosine x plus c2 sine of x. Okay, and then again, we're going to need a couple derivatives, because the whole idea is now, instead of c1s and c2s, we want to use a's and b's. I apologize for that. So the c1s and the c2s, those are what we use for our complementary. And then for the particular, we use the uppercase a's and the uppercase b's and so on as needed. Okay, so now we're ready for a couple derivatives, because the whole idea is we just need to solve for those undetermined coefficients, a and b. And we're going to go back to our given differential equation, but we'll need 2 derivatives. So minus a sine of x plus b cosine x. Just be careful, if this were like cosine 3x, this would be minus 3. Sine 3x would be 3b cosine 3x, so careful with those little items. Okay, differentiating again, we get minus a cosine x and minus b sine of x. Okay, so now the substitution. And I'll rewrite y double prime minus 4y prime plus 3y is 20 cosine x. Y double prime was minus a cosine x minus b sine x minus 4 times y prime was minus a sine of x plus b cosine of x, and then plus 3 times y was a cosine x plus b sine x, and that has to equal the 20 cosine x. Okay, so if you want to formally distribute, that's fine. I'm going to just pick them out. Let's see. For the cosines, to solve for the constants, we need to compare. And if we compare, let's say, the cosines, you've got a minus a cosine, this would be a minus 4b cosine, plus 3a cosine, giving us 2a cosine x, minus 4b cosine x, equaling the 20 cosine x. And we can divide out the cosines, so we get 2a minus 4b equals 20. Okay, we'll need to hold on to that. Because there's one equation with two unknowns. So therefore, we'll have to compare the signs as well. So comparing the sine of x, we get is a minus b. This will give us a positive 4a upon distribution, and then a plus 3b. So minus b plus 3b is 2b. Sine x. Well, let me put the cosines first, or the a's first. Doesn't really matter, but we're going to have to solve the system, it looks like. So I put the a's first. I've got 4a sine x, and then minus b plus 3b plus 2b sine of x equaling, oops, I'm sorry, I was drifting off there. And on the right, there aren't any sine x's, so we write 0 sine x. Then dividing out the sine of x's, we have 4a plus 2b is 0. Okay, so now we need to solve the system. And so 2a minus 4b is 20, and 4a plus 2b is 0. I'm going to divide everything by 2 here. So a minus 2b is 10. But then actually I'm going to leave that second equation because the b's are now equal but opposite. And so if I add them, get 5a equals 10. Then a is 2. And if we back substitute to get b, let's use, doesn't matter which one you use. Let me use the a minus 2b as 10. A was 2, so 2 minus 2b is 10. Minus 2b would be 8. And b is negative 4. So we've got a is 2. B is negative 4. And so therefore our particular solution, y sub p, is, okay, go back to what we took it as, a cosine x plus b sine x. So 2 cosine x, b negative 4, so minus 4 sine of x. Okay, so those are 2 typical types of questions. Next is a set of 2 questions on finding just the form for y sub p. So not actually solving for the constants, for the coefficients. So we start off as normal, and we form the associated homogeneous. So y double prime minus 10y prime plus 25y is 0. And then our characteristic equation, r squared minus 10r plus 25 is 0. This factors as r minus 5 and r minus 5. So r equals 5 twice. Or, in other words, r equals 5 with a multiplicity of 2. So if you recall, for our complementary solution, it's going to be of the form c1 plus c2x times e to the 5x. And then we're going to form our guess. And our guess for y sub p is based on the function x e to the 5x. So if you want to use your cheat sheet at this point, we have to include not only x e to the 5x, but a constant as well. So this is similar to number 7 here, x e to the 2x. Okay, so that's what we include. So this cheat sheet is helpful. And when we compare, we see that there are duplications. That is, there's an x e to the 5x involved. So there are dupes. So what we have to do is multiply by the least power of x so that there are no duplications between y sub p and y sub c. So in order to do so, you might consider, all right, well, an x alone, just x to the first, do it. Well, it would make this x squared, which is a good thing, but it would make this bx, and that would still be the same as this c2x. So therefore, we're going to have to multiply this by x squared, because then this will be ax cubed, this will be bx squared, and then there are no duplications between y sub p and y sub c. So our final answer is that y sub p is ax squared, ax cubed plus bx squared times the e to the 5x. Okay, so I'm going to stop right there. We're at the 22-minute mark. We'll come back and obviously finish this up. Probably going to be 3 or 4 parts to this, but I'm hoping you enjoy it as a nice, thorough review, just like we do in class.